Hey everyone, and welcome back to HSC Maths Tutoring with Nathan. Today I'm going to show you how to solve trig proofs with t-formula very easily. Okay. So, and first of all, identify when can you use t-formula. That's the first thing, and then we'll go over the process and why t-formula is better. So, to do t-formula, let's in the corner here. Before we attempt this, let's write the t-formula. So t-formula starts with let t equal tan theta on 2, that's the traditional. Then sine theta equals 2t on 1 plus t squared. Cos theta is 1 minus t squared on 1 plus t squared. And tan theta is 2t on 1 minus t squared. So this is the traditional standard t formula, but it's not the only instance you can use it when you have theta on 2 and theta. If you look here, this question, I picked this one because there's no theta on 2 and theta, there's instead theta and 2 theta. So the first thing, we can use t formula when there is a double angle pair, such as theta and 2 theta. Theta on 2 theta, or even 2 theta and 4 theta. They're the three you may see. This is the standard one. That's common, and that's rare, but I've still seen it. So as long as you've got this pair, you can use t formula. So then, once you identify a double angle pair, you let t equal tan of the smaller angle. So in this proof, my first step would be let t equal tan theta, because that's the small angle. I've got 2 theta here, and in the answer there's theta, which makes this question a lot better now, because all I've got to do is prove this whole fraction equals t. So now, once you've identified the t substitution, you should state it. You sub the t formula in. So obviously we're going to start with the left hand side, because there's no way we're going to turn tan theta into that. And just a note, with the t formula, this theta and theta doesn't matter. Like, as long as it's a double angle pair, these formulas apply. If t equals tan of that, sine, cos and tan equals that. So it's just a double angle. So these three formulas are always the same. It's just the angle here will change depending on what your starting t is, which means our left hand side is now 1 minus t squared on 1 plus t squared plus 2t on 1 plus t squared minus 1 all over 1 minus t squared on 1 plus t squared minus 2t on 1 plus t squared plus 1. Now what do we do now? This looks messy, but there's a trick, and this is the reason I would love to use t formula if given the option. So even if the question doesn't say use t formula, you're allowed to use it. The question just says prove. You can use any legal method. So what we do here is we always end up with a compound fraction, usually with t formula, because we're subbing in a fraction into a fraction. So what we can do here is multiply each term by LCD. If we look here, each fraction we look at has a denominator of 1 plus t squared. So what I'm going to do is I'm going to times top and bottom each term individually by 1 plus t squared. So I'm going to times all this with 1 plus t squared. And what happens is it's going to cancel the denominator, because that will cross out with that. So that's 1 minus t squared plus, now this has the same denominator, so it's going to cross out the bottom, and I'll be left with 2t. And there's no bottom here, so it's just minus 1 times that, so I'll have to leave it in brackets because there's a minus all over. And this is going to be the exact same thing except minus and plus change. So that's a minus there, and then that's a plus. I don't need to put brackets because there's no need. And look at that. I have now reduced this complicated looking fraction to a much simpler looking fraction. So at this stage we can just collect like terms. So 5 would be collect like terms, then factorize. We always want to factorize first before expanding, if we can. At the moment we can't really factorize anything, so we're still going to collect like terms. Now if you notice here you've got 1, and then this is minus 1, that's gone. I've got minus t squared, minus t squared, so that's minus 2t squared, and I'm left with plus 2t. On the bottom I've got 1 plus 1, so that's 2, negative t squared plus t squared, that's gone, and then just minus 2t. So now you'll notice I'm able to factorize from top and bottom because they both, the top has a 2 and a t common, so I can take 2t out. This is going to be minus t plus 1 all over, and the bottom they just have a 2 common, so then it's 1 minus t. And you'll notice these are identical. Minus t plus 1 minus t is the exact same thing, gone. 2 and 2 gone. And then we have equals t. Now at this stage, once you've simplified your fraction as much as possible, you sub t equals tan smaller angle back in, pretty much. So then that equals tan theta, which equals right hand side. Now some questions you won't actually sub this back in because the question won't want the answer as tan and want the answer as cos. But basically the right answer in format of the right hand side, whatever the right hand side is, you write it in terms of that once your fraction's as simple as possible. But the aim is if you've done it correctly, you'll have a very simplified fraction in t, and it's usually just going to be straight away the answer. That's why I prefer t formula, because it takes complicated trig and turns it into algebra, and algebra is much easier to deal with than trig formulas. Now this one might be a little bit more confusing, but if you have any questions, make sure to comment below. Otherwise, if you enjoyed today's video, make sure to give us a like and subscribe for more future videos. And also let me know below what videos you would like to see in the future for 2, 3 or 4 unit HSC Maths. Otherwise, I'll see you next time.